Addiction is seen as a physical or psychological need to take or use something, often to the point where it could be deemed as harmful to the individual. Symptoms of addiction include repetitive behavior, impaired control, strong urges to engage in said behavior, lack of productivity, and loss of quality of life. Although it is difficult to answer, technically anything can be deemed addictive. Behavioral addictions differ quite significantly from substance-based addictions, as behavioral addictions include the engagement in rewarding non-substance related behavior, such as gambling, video gaming, or excessively working. However, today we are going to be focusing on substance-based addictions. This type of addiction differs from behavioral-based addictions, as many factors and symptoms are solely unique to the specific substances ingested and the individual themselves. Addictive processes, tolerance, withdrawal, cravings can all be seen with behavioral addictions, but are much more prevalent in substance-based addictions. Addiction often begins when a stimulus originally ingested or utilized to create a feeling, often considered enjoyable both physically and mentally. This can often awaken a powerful urge to take or utilize the object or behavior to create that original feeling again. When addicted, withdrawal symptoms are often identified as unpleasant. So as a means to counteract these negative feelings, the addicted individual will generally continue to engage in their unhealthy activities, often resulting in a cycle. This cycle will continue and likely become out of control as more and more will be needed to satisfy these cravings to achieve the same high. Serious psychological and physical effects can often be seen in the cases of substance abuse. Addiction is considered a disease.
Dopamine is a neurotransmitter whose effects can be either excitatory or inhibitory. It is present in brain structures such as the dorsal striatum, the substantia nigra, and the amygdala. The role of dopamine in reward can be seen clearly in 1970s experiments, where rats would self-stimulate small electrodes in dopaminergic neurons in the brain, and the drugs which would impact dopamine led to the rats self-stimulating more. Dopaminergic neurons of the dorsal striatum and substantia nigra have been associated with goal-directed behavior and habit. During the binge intoxication stage of addiction, increases in dopamine transmission promote habit formation. However, the response to dopamine becomes diminished with use and will lead to changes in the dopaminergic neurons in the prefrontal cortex. This leads to compulsion. The consumption of drugs and alcohol increased dopamine in the ventral striatum, causing the feeling of euphoria due to D1 receptor activation. D2 receptors do not cause drug reward effects and are believed to even reduce the reward effects. Only D1 receptor activation will cause the reward effects. Dopamine has been widely understood to be a key mediator in motivation. Changes in dopaminergic systems have been implicated in shifts in executive function, from prioritizing long-term desires to prioritizing instant gratification. Within system neuroadaptations is the name given to neuroplastic changes seen in addiction at a chronic level. These effects are due to the cell trying to reduce the effect of the drug, but that such changes persist even after the drug is no longer present. Reduction in dopamine transmission in the nucleus accumbens in withdrawal is an example of this. Decreases in the number of D2 receptors and decreases in dopaminergic activity are within system neuroadaptations that occur with chronic alcohol use. This leads to a loss of reward response from things that would otherwise be considered natural rewards, manifesting as a loss of motivation and pleasure from doing things other than drinking alcohol. This is seen in the withdrawal negative effect stage. It has been suggested that the compulsive behavior seen in addiction may be explained by changes to the dorsal striatum. This position has been justified by research indicating that the motivation to eat is associated with changes in dopamine levels in the dorsal striatum, and thus may be applicable to the motivational changes seen in addiction to drugs too. D1 receptors are implicated in a mechanism called incentive salience, where certain predictive cues are associated with certain rewards. These cues would previously have been neutral, but over time the association between the cue and the reward become reinforced. This has been studied in some depth. For example, in primates, it was noticed that midbrain dopaminergic neurons would fire in response to a new reward. With repeated exposure to that reward, those neurons didn't fire in response to the reward anymore, but rather they fired when exposed to predictive cues for that reward. The association between the cue and the reward increases the motivation to seek that reward and explains cue-induced drug-seeking behavior.
The mesolimbic reward pathway is an important part of how dopamine relates to drug addiction. Dopamine is the primary neurotransmitter when we discuss this pathway. We are also aware that drugs of addiction, for example cocaine, nicotine, etc., can act both directly and indirectly on the mesolimbic reward pathway. The mesolimbic reward system is comprised of dopaminergic neurons which begin in the ventral tegmental area. These dopaminergic neurons have axonal projections terminating in fields in the nucleus accumbens and the prefrontal cortex. Certain drugs will act on different parts of the mesolimbic pathway. Depending on the point at which the drug acts, as well as for the length of time use occurs, the severity of the dependency will be determined. Heroin, for example, can trigger activation of the mesolimbic pathway at an early stage, the ventral tegmental area. It also acts at the nucleus accumbens. This leads to the eventual release of dopamine. Evolutionarily, the brain sees this activation as beneficial, the completion of a task related to survival or reproduction, and we therefore retain the knowledge of how this activation occurred with a motivation to replicate this process. The pathway is often referred to as the reward pathway for this reason. It is designed to promote evolutionarily beneficial activities and attempt to replicate them. For example, eating nutrient-rich food. Heroin, as well as alcohol, nicotine, and cannabis, all have their own receptors in the brain that they are able to bind to directly and increase the levels of dopamine in the mesolimbic system. Opiates act as agonists at mu, delta, and kappa receptors. Nicotine targets nicotinic acetylcholine receptors, and cannabinoids target CB1 and 2 receptors. Other examples, such as cocaine and amphetamines, act indirectly on dopamine in the body. Cocaine, for example, simply inhibits dopamine transporter. This blocks dopamine reuptake and therefore increases the synaptic dopamine. This repeated stimulation leads to changes in the body in order to compensate. High levels of dopamine being released regularly leads to decreases in the levels of dopamine receptors in an attempt to equilibrate. This happens with regular use of methamphetamine, heroin, and cocaine. These changes in receptor numbers mean a smaller reward for the release of dopamine. It is the same biological process Andrew discussed with alcohol. This dopamine relationship with addiction is tied in with one of the two key theories of neuroadaptation in addiction, the opponent process. Opponent process suggests that drugs cause both positive and negative feelings. Upon the taking of said drug, one will predominantly experience the positive feelings associated with it, for example, euphoria. After some time, these positive feelings will be substituted by the more negative ones as your body attempts to regain equilibrium, for example, hangovers and withdrawal.
There are treatment avenues for the addiction to drugs and alcohol. However, it is not simple. As addiction is considered a chronic disease, sufferers cannot usually stop for a few days and suddenly become cured. These individuals will likely have to undergo long-term and repeated treatment, with assistance that will help them completely stop the use of the negative stimulus to best assist them in becoming clean. The primary goals for treatment include the discontinued use of the drug and/or drugs, actually remaining drug-free after the intervention, becoming a productive member of society, and potentially forming and migrating into a healthier family and work environment. Based on scientific research since the mid-1970s, the following key principles should form the basis of an effective treatment program. Whilst counselling and aftercare support address various mental and emotional problems associated with addiction, medications remain somewhat effective tools to assist in breaking the cycle of physical dependence, helping to ease a difficult withdrawal period. These medications, however, still possess certain risks of their own. To assist in certain aspects of addiction, a patient may be prescribed medications that diminish the cravings and withdrawal symptoms, combat intoxicating effects, or have off-label uses that support the individual in recovery. Drugs that may be used to manage drug and alcohol dependence, or have at least been viewed as part of an addiction treatment regime, include drugs such as naltrexone and buprenorphine work by blocking the receptors in the brain that opioids would otherwise bind to and activate, therefore preventing opioids from eliciting their addictive high. Medications that assist individuals struggling with alcoholism include disulfiram and acamprostate. These drugs work by resulting in a very unpleasant reaction when the individual consumes even the slightest amount of alcohol. Disulfiram achieves this by blocking the activity of specific enzymes important in metabolizing alcohol.